Well, good morning. Today's video is going to be about setting up, adjusting, and using the RCBS Lube-a-matic Lubrisizer. But before we get going, if you like the video, please subscribe. Give us a big thumbs up so we can kind of mess with YouTube's algorithm, and smash the bell down below so you can be notified of any newer videos. All right, I picked this up at an estate sale. Gentleman was a reloader, passed away, and his family was selling most of his stuff. This one is brand new. There was no lube in here where the dye is. There was no top punch in here. There was a stick of lube in here, but it had never been compressed. So I'm assuming he bought it, was going to use it, and was never able to do it. Family was nice enough to throw in this heater to soften up the lube. So we're going to hook both of them up and see how they work. The reason I've never done this before is because traditionally, for me anyway, I've always powder coated bullets. This is a 201 grain semi-wad cutter, 45 ACP, and I've always been real happy with the results of powder coating. I've never done it this way. So today we're going to have an opportunity to use this, see how it compares with the ease of powder coating bullets. And okay, let's get on it. The first problem we ran into is I don't have any cast lead bullets. All of my bullets have already been powder coated. So I think we're going to have to cast a few bullets. And this video is already taking a left turn, but it'll be interesting. I'll show you how we do our castings and how we test for lead hardness on our bullets. We're not casting rifle bullets. These will be pistol bullets. So let's get set up and get the pot cooking. Well, I was getting ready to heat up the pot, and I realized I didn't have any alloy prepared. So again, we're going to take another left turn with this, and we're going to prepare some alloy for casting. What we're going to try to do is duplicate the Lyman number 2 alloy. What we have here is linotype, and this is pure lead. The linotype is pretty hard. It has a BHN of 22, and the pure lead has a BHN of 5. The Lyman number 2 casting alloy will get us somewheres around 15. So we're going to combine these two by weight, proper proportions, melt them down, get some ingots going, and we'll get them into the pot and we'll show you how we're going to cast them. Hopefully we've got everything prepared. Well, welcome back, and we've alloyed those two metals together into these ingots, and we're going to get them into this old Lee pot and start getting them melted down. Pot is tired. It's been around for a few years. The mold that we're going to use is an RCBS, and it's going to be throwing a 201 grain 45 caliber semi-wad cutter bullet. So let's get the mold heated too, and the way we do that, kind of let it sit right on top there, and everything kind of heats up together. As soon as we're ready to cast, flux, we'll get back and show you how we do it. Hopefully we're going to get to the Lubricizer real soon. Okay, our mold is up to temperature, and we're ready to start casting. This is where the OCD kicks in. When I drop lead into a mold, I like to drop it right in the center there of these holes. Very often you'll see guys casting, the lead hits here and dribbles in there, or they hit it here and try to fill up both of the wells at the same time. I kind of believe that if you go dead center, you're going to get a denser casting and a more detailed casting. Let's see how it works. You want to have somewhat of a sprue because as the metal cools, it's going to shrink and contract. Let's knock that off and take a look at these bullets. Nice sprue. Let's knock that off. Nice bases. And if we open this up so you can see them, nice looking bullets. Real nice. Okay, let's continue. Well, here's what we managed to produce in about a half an hour once the mold got up to temperature. There's some real nice bullets, beautiful bases on them, nice and crisp castings, and the alloy that we put together seems to have worked pretty nice for casting ability. One of the things we're going to do is we're going to test the hardness of this alloy on these bullets. And the way we're going to do that is with the lead hardness testing kit, and we'll show you how to do it step by step. But one of the first things I like to do after casting them is to weigh a couple of them. In the past, when I've scrounged around for lead, I've gotten some mystery metals and I would cast bullets with them and they didn't weigh anywhere near what they were supposed to weigh. So now we just test a few of them. These are supposed to be 201 grain bullets. 206, that's not bad. 206. Let's grab another one or two on our scale here. 205 and 206. So they're pretty much in the ballpark. They're not excessively light, which is what happened to me one time when I had those mystery metals. So I do check the weights of several bullets to make sure they're in the ballpark. And now we're going to test the hardness, and I'll show you how we do that. Okay, we've completed the casting of these bullets, but before we start to lubricate and size them, we're going to test the hardness of the alloy that we made, and we're going to be using the lead hardness testing kit. It's really pretty simple and straightforward, and we'll demonstrate it for you on these bullets. The first component is this die that's going to go into your regular press. And if you look carefully at the tip here, there's a ball. I think you can see that. And what we're going to do is we're going to depress that ball into the lead sample for a predetermined amount of time. 30 seconds is what the instructions say. How hard are we going to pull down on the handle? Well, on the other end, there's a hole here, but there's a piston in that hole. And when that piston reaches the top here and it's flush with the top of this die, that's when we start counting 30 seconds. What's going to happen is that ball is going to indent our lead sample, and then we have to measure it with this little pocket microscope that they give you. I can't put this on the lens to show you, but in the instructions there's a little diagram right here, and you'll see the indentation that the ball made into the lead sample. We'll measure the diameter of it, and then in the chart here that Lee gives you is a conversion formula, and depending on the diameter of the indent, it'll tell you what the BHN of that particular lead is. So let's try a bullet and see where we end up. Remember, we were aiming to duplicate a Lyman number 2 alloy. Let's see how close we are. Okay, we're ready to set up for our hardness test. And the first thing we're going to do is screw in this indentation die. According to the instructions, it doesn't matter how far down you go. It's not like resizing a case or seating a bullet. You just get it all the way down. And then we're going to tighten it into place. You can see it protruding right there. And let's just kind of snug it down a bit. There we go. We've already installed the cradle that's provided with the kit, and this cradle will hold the bullet steady, not roll around. Now what I'm going to do is look for a flat surface on this bullet, and I'm going to use the driving bands for it. And we're going to set this bullet and line it up so that the ball will touch right onto that flat driving band. There we go. And this is where we're going to apply the pressure. Now the thing to watch is right up here. We want that piston to come flush with the top of the die as we apply pressure. We don't want it beyond that. And there it is right there. We're going to hold it right there flush, and we're going to count for 30 seconds. At the end of 30 seconds, we should have an indentation in the lead that we can measure with the microscope. Okay, 30 seconds is up. Let's lower this down. And sure enough, we've got a nice indentation. I'll show it to you, right here. There it is. Let's take a look with the microscope. I can't put the microscope on the camera, but I will look through it and we'll measure it. And according to this, it measures 0.57 in diameter. That indentation, 0.57. Okay, now go back to the chart. And the diameter, 0.57. This shows we have a Brinell hardness number of 16. That's pretty close to what we were aiming for. I'm real happy with that. So we're going to go ahead now, finally break out the Lubricizer, set it up, and see if we can lubricate bullets the conventional way. This is a fun gadget, by the way, and if you're concerned about your lead, what you're mixing together, it's a great, easy, fast way to test for the Brinell hardness number of your lead. You want to cast rifle bullets, you want a harder lead. Bullets we're casting could be a little softer today. Great gadget. It's a little pricey, but well worth it. Okay, let's get to the Lubricizer finally. Okay, we're finally getting to set up the Lubricizer. First thing we're going to do is attach the heating plate to these two pieces of wood that I've glued together. My idea is to clamp it onto the bench so that I can remove it. Obviously don't use it that often, so we'd like to store it, keep the bench free, and put it in when we do need it. So first we got to do is get this thing screwed down to the plates. And hopefully keep everything pretty solid. And the last one. Okay. That's pretty solid and the clamps seem to be holding good. Next, let's get the Lubricizer and put it in here. And that has two screws. Let's back you up a little bit. And these two are going to go right in here and secure it to the heating plate. And one on the other side. Okay, let's tighten them down. That's pretty secure. Next thing we want to do, we know that the lubricating material is already in here, but we'll double check it. We'll take it out and double check. And we got to put in the appropriate dye for sizing the bullets that we've got. Let's take a close look at this. Okay, the first thing we're going to do is, there's a sizing die in here. It was there when I bought it, and I did look at it, and there was no lube in here. But it's not the size that we're going to use today. So let's get this out of here. I've already loosened it up. And take a look at it. And this is a 452. That could be good for long Colt. Anyway, let's take this off of here. There we go. And the one that we're going to be putting on is a 451. RCBS 451. And this will be perfect for sizing our 45 ACP. So we'll get it down here and we'll get it tightened up. That's pretty good. The next thing we want to do is insert the top punch in here. The correct top punch for the bullet that we're using is going to be this one here, the number 680. So according to the instructions, what we need to do is loosen this set screw right here. See if I did it enough, and then insert all the way up to where the shoulder touches the die. And then we're going to tighten it right up. Hold that there so it doesn't drop out. And the next step, according to the instructions, is to adjust this height. And this will determine how far down the bullet travels to get lubed properly without excessive lube, and also sizing it at the same time. So let's see what we've got to do for that. Okay, we're ready to adjust the height of the ejector pin right here. And that is done by turning this large screw nut all the way down as far as it goes. The next thing to do is to grab this knurled knob and turn it till this piece is a 1/2 inch below the die body. That's a good starting point according to the instructions. So let's get that turned up. And we'll get it approximately a 1/2 inch. And that'll be a starting point. And what we're going to do, which we probably should have done already, is turn on this heater and soften up this lube that's in there. I don't know how long it takes, and I'm not really sure which setting it should be on to start with, but we'll put it somewhere in the middle and we'll see where it goes. Now that's just about where we want to be, a little bit more, and that'll be a 1/2 inch. That's perfect. Okay, good. Kind of lock it in place, and let's get this thing turned on. Okay, I'm not quite sure where to set it, but we're going to turn it on, and that's high, that's low, so let's start in the middle somewhere, and we'll kind of time it and see if anything's getting warm. The next thing they suggest to do is to take one of your bullets that you're going to size, the first one, and take some lube and get it on your finger. Why not? And lube the rings with your finger. They suggest not getting it into the grooves of the bullet, but just around the outside, these driving bands. Kind of lube it up, and that'll be your first bullet that'll go in there. So let's just place that there for now until the heater plate gets going and softens up this lube. Let's take a look. We'll be right back. Okay, I've been playing with this thing for a little while, and some of the adjustments that I found out are very critical is the distance from the top of this ejector pin to the bottom of this die cavity. That's adjusted by turning these knurled knobs down below. Look what I managed to do when I had it improperly adjusted. Big glob of lubricant all over. However, after playing with it for just a short while, my bullets were starting to come out like this. Grooves filled up nicely, and by adjusting the pressure on the top, I could fill them up a little bit more, and they're sizing really perfectly. Let me show you how it works. Well, once it's adjusted, it's a pretty smooth operation. We take one of our newly cast bullets, place it right into the die. Handle comes down all the way, and we give our top handle a little bit of a turn. And what that does is it increases the pressure in the lube, forces it into the die, which forces it into the grooves of the bullet. Up it comes, and our bullet comes out nicely lubed. Now let's check the diameter. Let's put the gauge on here. And we're reading 450. That's pretty good. So although it took a little while to get it adjusted, and it took us a little while to get the thing set up today, I'm pretty happy with it. We'll continue to play with it, and I'd probably like to get a little bit more lube into those grooves, although that may be enough, I'm not for sure. The other thing I did wrong was in adjusting the heating plate for the lube. I had it set too high, and it was making the lube all liquidy and everything, so I cut it down quite a bit. I guess it's a trial and error thing, and we'll figure it out. Well, anyway, I'll keep you updated on how this thing is working, and if it works this easy, I may not go back to powder coating. Thanks for watching, and if you did like it, please give us a thumbs up and ring that bell so you'll be aware of the next video coming out. Thanks a lot, and have a great day.